room. So in this way we can see the traditional way of working with all of the layers, and from a side view we can see that this information is absolutely flat, so there is no 3D information. I will define a contour as a footprint around my building, choosing from a particular part of a wall type, and this wall type can be set around the building with the recognition of the snap points of the 2D file. And by closing this contour with the floor and the ceiling, we are entering the first step into 3D. As you can see, I'm now representing the 2D file with a 3D model, and from the model I'm going to insert spaces, which are very important for doing the installation building services part. So with the recognition tool inside DDS, I have told DDS to use the contour which was on a specific layer, and what I now can do is I can click inside the room, in which the room, not only from the contour itself but also from the naming and numbering, is recognized in DDS. So we can see here that the name 0.8 or 1.08 is reused and recognized from the 2D file. I can do this for every room, and you can see that not only the room itself but also the door is recognized. So this is a first step of doing a quick rerun on the model, because for us it's important to have the building information inside. When we now click to the 3D part, we can see a building arising. And when we change to the render settings, we can now see that from 2D file we can have multiple floors, we can have multiple spaces, and also the doors are recognized together with the windows. So when I click inside the opening of a window, automatically recognized from the width, and of course there is no information otherwise than the width from the window, so I cannot say something about the height of this. The information which is not available can be added and can be changed afterwards. Something is wrong as when we can see it is not correct. So for example, these windows which are now are selected can be changed directly. By changing all options for my window, I can see, okay, the width is standard, but I would like to have a different height, for example 1.40 m, and I would like to have a sill height of 58 centimeters. So this is now created for all of the building models. And in the traditional way working with DDS, these kind of information from the building model, as we can see from here, that we have included 9 rooms and that we have added from the room list inside DDS, also a room list, also the information from the specific rooms. So it's not only the reuse of the graphical format, but also in DDS we are putting up or building up a building model, and we can see, for example, the materials used, or we can see, for example, the U values used for this kind of information. And this can be all mapped and changed by doing a heat load calculation, and also from designing our airflow and air requirements together with our heating facilities. The importance to have a building model is of course very high. From this part, this could be the first step by investigating what is inside this 2D file, and with some minutes we can have an output like the building model together, what is the room area and what are the volumes. Information 2D for building services is not enough, it's not sufficient, and we need to transport these information into 3D. So we have an area, not only, but we... Right, this is the first step of doing tradition. So when I turn off, for example, the 2D file, we can see that the info is still there. So the information from the size of the room and also the numbering is still there coming from the 2D file. And of course, when a new file is imported, we can have a function to be changed between 2D traditional tools. Right, for example, on electrical part, something on light fittings. Because of the room is recognized, we close the room to the room height fixtures, and we can define the surface of the ceiling, and we can say we would like to insert 4x4 light fixtures. And this is something I also would like to show you later on. When we have the building model, we can extend the information from our building services directly to the. So when we now turn on the rendering and we hover towards one light fitting, we can see that this light fitting is now located in this particular room. So we can extract bill of quantities, and from the bill of quantities we can extract also a structure that we can have, for example, a setting towards a listing of each rooms, so which components are used for each room. And of course this can also be reported and exported. Right, I think it's now time for going to the next step, in which we would like to have not only the traditional way of working, but working with an intelligent building model. And for this I prepared another project. It's called Webinar 30th of May. And for this we would like to start with our ground or deep foundation. And I will not start with a 2D file right now, but I will start with an intelligent building model. And from the intelligent building model we are going to use the same setting by moving or copying this specific file into our project directory. And this project directory will have the other setting here. So we will copy the file, and what I did before with the 2D file for just one floor can now be done for the entire building model with an insert of not only the file but insert of the IFC file. And this is the building smart data model in which the building information is included. When I now choose to open up and import this file, we can have a function to say what kind of information needs to be put in what spot. So we can import and convert to DDS objects, and this is the most intelligent way. So of course the architect has thought about the sizing of the window, and maybe he has created or did a calculation for the U value of the window, or the function of the room is not yet linked to the model. And this information is for us on building services and on MEP important. So what we are doing is reusing the information from the architect, and by using the import function and converting, we can now directly link every object to an object of DDS. So the import is now done, and when I look, for example, to my ground floor, we can see the complete and entire building model arising. And because the information from the building model, when I open up the building information, we can see that we have on our ground floor 18 rooms listed. We have 11 rooms on the first floor, and at our second floor there was one big room. And we can also see the story heights, and these are all coming from the intelligent building model. So for this information I don't need to to have any time spent on investigating the height of the stories. And this is all coming from the building model, and this can be directly reused. Within DDS, the first step I did was in the traditional way of putting up a contour. But you can see from the building model right now in 3D that not only the building model but the entire building is recognized. And as you can see here, this is a specific view inside DDS. And we can also have a different view by clicking or a more advanced render setting. So I will open up another view, and now we can look through the windows, and even inside the view we can also have shading inside this model. So this is just a representation of the building model which was imported from the IFC file. So what I now would like to do is to show the information, for example, for this specific rooms. So I will put in room text, and as we can see here, the room text is set together with the corresponding number and naming, but there is much more information behind. When I double click not only on the numbering and naming, I can also have the information for heat loss. And this is a prepared model, but I can show you what kind of difference the heat loss will make. From our building model, important to know is that the corresponding U values are set. And what I did in this case is mapping the information, for example, from this specific room or specific window, mapped to a DDS object. So I'm adding information to the information which is directly coming from the architect, but the information I need is more extensive, is much more information on temperature, on ventilation requirements, and also, for example, electrical calculations on lighting. So what I'm doing is mapping the information, and once the mapping from the object is recognized, it will stay intact of the system. So every time I'm using a similar IFC file from the same architect, the information is already mapped and can be done and directly used for doing calculations. So right now I would like to start with the technical discipline, and the technical discipline, first one would be ductwork. So what I will do, I will open up the ground floor and I will do dimensioning and first of all a calculation of air requirements. Then I will put you to duct system and I will calculate also the duct system in which also the automatic dimensioning will be created. So you can see from the setup in the ductwork model that we have a different toolbar, but from the building model we still have the same information, and the information is now added with airflow requirements. So first of all, we have to choose what kind of ventilation system will be used in this case. Do we have a variable air system, or do we only have extract air only, in which we have natural ventilation? When we use a function of a combined supply and extract system, we can have our calculations set directly corresponding to the settings of the room specification. So each room is defined inside the model to be set as a supply type room or an extract type room. And this information can be set and seen directly from the room information. So we can see here that the meeting room is not set to any system on required airflow. But in this case, when I go to an office, in this one, we can see that the function of the office is already connected to supply. So what I did before, by adding the room text, I can also add the room text on my ventilation part. And when I now click ventilation and we go into a specific room, we can see that our room needs to be ventilated with 71 cubic meters an hour. So this information is a direct result of doing a calculation, and now I can dimension in my system based on the information and airflow requirements of the building type. So first of all, let me open up my room list, and from my room list I can identify whether the corresponding functions are set yes or no. So I can see from my bathroom this is set as an extract room. And I can also see that my meeting room is set to no ventilation. So this will influence, of course, the complete otherwise of the system. So I will search for my meeting room, which I can open up from this side. And this is my meeting room. I can now say I would like to edit the information. And that is something which is very powerful inside DDS. With the information which is provided, we have to do our designing part. And sometimes the information is not yet complete or not yet well designed. So we can say, okay, for our base of expertise, for this meeting room, we really would like to have a supply and extract. So this kind of information can be added by us, by our experience. When it is not correct, or when the function of the room is changed, we can easily change from supply extract to supply only. And when this would be a complete bathroom, we can set it to extract only. So the information can be changed very rapidly, and we are even still possible of doing recalculations. So when we look to this room, we can see that we don't need any air because there was no room settings requirement set. When we rerun the calculation with a new setting for this particular room, I get a message about trying to do balancing, and we can now see by repaint that we now have 96 cubic meters an hour needed in this particular room. So this is reuse of the information. It's like designing, adding information, and also from our expertise and point of view, we can say, okay, now we are ready for designing our pipe system. So what I will do, I will open up my roof on top of the building, and I will put an air handling unit in here. And either we can start from the air handling unit or we can start from the terminals inside the specific rooms. For us, the start and the endpoints are completely flexible. So when I say I would like to have an air handling unit, let me see, generic scalable, generic extract supply, we can have an air handling unit with a heat exchanger included, with extract above, supply air above. So there are many settings from the database, and the database of DDS can be opened. So when I copy a function here, I can also say, okay, I will put in my own ventilation unit, and I will call it number 2, and I would like to have a different length, for example 3 meters, 1 meter 5, and the height is also 1 meter 5. So these information can be changed and added directly to DDS. So I will put somewhere on the roof, I will put my air handling unit, and when I look to my front view, like here, I can see that it is located directly on top of the roof. Going back to 2D, now I will go from my intelligent model, because it's not only a model, it's not an object with lines, it is also an object with intelligence. So there is a connection for supply air, there is a connection for extract air, and there is also a connection which we can see here on the right side for heat return, for example. So the 2 lines I would like to connect right now are extract air, and coming from this object, in this case we have a flat duct coming out. We can stop to the next floor, and what we would like to do sizing of this duct system, we can easily change from the model, we can change predefined type. So this is a 300 millimeter, 50 millimeter coming up, and when we now change it, it is also changed from this part. I would like to also start for doing the supply, and for doing the supply we can see that we first have to go up for a minimum of 2, and we can go over our extract, and we can also drop down. And this information, of course, in 2D can be viewed in 3D. We are able to work as well in 2D as well in 3D, but most of our users and also our installed base are working in 2D view, and for doing checking, for doing classification, or for doing, it can use also the 3D view. So this is our unit, and whether the information is correct or not correct, this is what I would like to start with. So in relations to my experience, I will drop down to my ground floor, and I will pick up the settings or the connection points. So I will open up right here, and there we have a connection point. Let's see. We will have a connection point available here. First of all, I need to drop down a little bit for creating an event, and then I can go across my system, maybe to this particular place here. I can drop down back again to the ceiling, or to the floor in this case, and I can now draw this one, and this can be drawn the other way around here, and we can have also connected in here. So we are building up not only an intelligent system, but we are also building up the system to be calculated. So as I can see right now, I'm dropping down into a specific wall, so I need to make changes for this endpoint. So what I will do, I will move this band a little bit back to be sure that where we drop down into the next floor, the space is also available. So this is my first floor, and from my first floor I can say, okay, I would like to go a little bit down, and I would like to go through my entire building. So this is going through the entrance hall, and from the entrance hall we are going to this floor, and I will go to my ground floor, and I will continue also this ducting system. Let's see where we have the information. Ah, right. Yes. In this case, I didn't continue with my bend down to the next story. So what I can do, I can change this bend by a T, and what I can do, I can still continue from this T, I can continue to the next floor. So this is a part being done in 3D. So now they are continued onto the ground floor, and once again from the ground floor I can make the connections. So I will come out either to my building, to my hallway, and I can go along this corridor, and at the end point of the corridor I can end the duct even with a duct end, a stop end, or even with a load. So for now I will close it with a lid, and I will do the same for my extractor. So in this case I'm coming out at 20 centimeters below the ceiling, and I will go to this specific room, and I will also close with a stop end. Once the system is finished, I can also say I would like to start on a bend, and automatically the bend will be changed into a T part, and I can continue directly from here and stop with a stop end. Of course, when I would like to do the same thing, we can have the function of the bend here, and because we are at the same height, we will have a clash in here. We will have a clash with our extract air. So for now I will leave the clash, and later on we will see how we can solve this clash, because that's also one of the important things. Once something is finished, we have to change because of the regulations, or because we have electrical components, or we have sewer system coming through. So now I've started with my system, and I will open up all of the floors, and I will, which are now recognized. When I see to my system, and I will turn off everything else from my layer settings, I will turn off everything, so I just have to have my ventilation, so only my ductwork, rendering, okay. So I will turn off everything else, all inverse by this, and I will change here in inverse, then I'll keep only my ventilation system. So this is what we have done right now. So we're coming from our air handling unit from the rooftop, we can go directly to the different floors, and we can come out on different levels. So going back to the ground floor, we would like to insert some terminals. So we will have a supply terminal inside the specific room. We can say supply, we have an air valve inside our ceiling. And once we have a suspended ceiling, of course, we can also set the relations to the suspended ceiling. So first of all, I would like to insert the suspended ceiling. Suspended ceiling is set to 2.2 meters, for example, in this room, but also in this room. So this is just by clicking. And when I now say I would like to insert my terminal, we can have once again inside the ceiling, but now it is linked to the suspended ceiling, and we can now see also what our elevation is. So the suspended ceiling is now set to 255. This is the building, but when I click inside a specific room, and I will point into the middle of my tiles like this, when I now look, it is related to the 2.2 meters of the suspended ceiling. So this is my air terminal, which can be connected, and I will do the same thing on supply. Then I change another, sorry, this was supply. I can do the same thing for extract, and for extract also using a different one, for example this one, also connected to the suspended ceiling, and I can put it on the other side of my, my duct, like here. So I would like to have a small part coming out in this case, and I can use different materials. So from rectangular duct I can also have a saddle to a round duct. So I can say I would like to have 125 round duct, and then the round duct is coming from here, from the saddle, and can be end somewhere here with the stop end. So I would like to show this, or to view this in 3D. I'll select the components, and I'll switch to 3D, and I can see, okay, I'm coming somewhere with the round duct, and I would like now to make a connection from my terminal. So what I can do, I can select the terminal and I connect within using a direct connection or 90-degree bend. When now looking to my render and turn on the render function, I can zoom to the specific location, so I can turn it off, in this case the covering, so I can look inside the model. So this is my suspended ceiling. I can say I would like to have a transparency for my suspended ceiling, so that we can look inside the room and still see the suspended ceiling. So the connection type is done automatically. We can do this also for our supply part. And the supply part will be used with an automatic function by connecting it to a rectangular duct. And so this is a repaint. And because of the terminal type itself, we can have rounding as a color saddle. And when I think, okay, this is not very nice, I can redo the information quickly. So what I can do, I can say I would like to delete, and I would like to start with a free end in here. And with the free end, I would like also to start with a rectangular duct. So I would like to start with the T part. And the T part is the same from here. So now I can say I would like to have a stop end. And what I can do is now I can move this one directly. 1 second. I will place it in the middle of this segment, like this. And when I now say I would like to make the connection, we can see that the connection is made directly to the top. And of course in 2D it's hard to see, so I switched to 3D. So I changed in here, I changed the connection type. So we can see from here. So I have to do a reconnection of this terminal type, and once we have one terminal selected, we can have a copy of this instantly. So when I say I would like to have a supply on this part, and I would like to have a supply on this part, and also on this part, but I also would like to have a supply on the other side of my supply. So I will make a twist like this, and I will have like here. So this can also be done for my extract, for my supply, sorry. This can be done on the other side very quickly. And it can also be even done on the big branch. So creating a system and multiplying once something is engineered, it's very easy in DDS and also very flexible inside DDS, because this terminal needs to be moved to this specific spot. So we can have it here, and maybe this one or the terminal could be changed or moved from here to here. So this is just an example. Whether it can be done or whether it's okay, I don't know yet. So this is my primarily first design. So right now I do a reconnect, so everything will be reconnected. And when looking now to my building model in the entire building, we can see here that there is a system arising. So here we have round ducts on the vertical ducts, and maybe it's a good connection, maybe it's not a good connection. What I can do, I can change this one from round on the ground floor to rectangular. And then once again I can say I would like to have a T part, and the T part should be on that part. And now this is changed again. So it is all about doing something and seeing, okay, this can be done, or this can be optimized, or this is not the proper solution, and we can reconnect very easily. So from our building requirements, we can now see the information directly from our system. So I'll switch back to my roof function, and from my roof I will point to the start point of my ventilation system, and I can say I would like to use this as a supply air calculation unit. So by pressing calculate, we can see the entire system now, and this is coming directly from the airflow requirements from the building model. And from the building model, I can make a step to my calculations tool, and we have started with the 300 times 50 millimeter duct. And DDS is proposing that this duct could be minimized or could be reduced. But of course, I must realize that I've just done some small rooms. So at the end point, maybe when I say I've connected not only the ground floor but also first floor, that the dimensioning of the system should be increased. But from the basis of my endpoints, for example, the velocity 6.5 is a result, and we can see that we are doing calculations based on a maximum velocity of 6. So this is what DDS tries to do the calculation or doing the optimization. So what I will do in this case, I will only adjust the air terminals and dampers. So the system will be calculated, and all of the components from the velocity but also from the absolute pressure loss will be set to the building model. So I will open up the ducting on the ground floor, and I would like to investigate in here. I would like to investigate what kind of flow and velocity is on this part. So I can point out this part, or I can point out this part, or I can point out this part. And what we now can see that, right, I did not calculate this part of the system. 1 second. I would like to investigate this part. Yes, right. So in this case, the terminal itself could also be set as a calculated value. So these are the settings directly coming from my calculation. So this is calculated from the supplier. I also would like to calculate from my roof part also the other one. So what I'll do, I'll switch to 3D, and I will select the start point in here. Let's see, this one, extract there, and I can do the same calculation by only adjusting the terminal set, and now the information will be transported also to the information on my drawing. And now you can see that we have 400 cubic meters per hour in this segment. And someone who is doing engineering on ventilation can tell me whether this value is correct or not correct. So we can investigate, like, okay, from every terminal we have the 100, and when we look to the room information, we can see what kind of air terminals are set in here. We can see our room area, we can see the calculated air volume, we can also see the maximum air volume, and we can also see, okay, this one is now an air valve. When I click on the air valve in here, so pointing to one, we can also investigate the pressure loss on this particular air valve. So this is now automatically. We can also set this one to 80 manual, or we can have it changed in here, and we can rerun the calculation. So this is about the flexibility of working with DDS. One part of the segment. So when I double click here, we can see that this is a flat duct system, and the flat duct system means that this could be a flexible duct. But what is flexible? For example, when I move this segment, or 1 second, I will change. I will change this one here. This could be part of flexible. And what I now can do, I can say the last part should be real flexible. So not only the name flexible, as we can see here, but we can also have a flexible with, for example, some part of insulation. So now I'm changing the last part of this segment. And what I can do, I can now convert it to a flexible duct. So now it's not only a duct in which, for example, when I change the location of this terminal, that the rest of the pipe segment is still rich, but when I now move this one, we can see that it is a flexible duct. So this can be also seen in 3D. Zoom out a little bit to the specific flexible duct. So we can now see that this is a real flexible duct. And we can once again optimize by avoiding clashes. So we can say in 2D, I would like to have a different setting like this, for example in here, and we can see directly in 3D what will happen on this part. So wrapping up the ventilation part, when we look to our bill of quantity, every segment from spiral, also from T-parts, also from the end gaps, and also from the saddle, from our valves, and also from our ducting system can be exported. And we have a function of doing an export, for example, to production lengths. And within the production lengths we also have a possibility of branch numbering. And from now a report is generated. And in the report we can have an extensive bill of quantity in which also the T-parts are listed. So when I move a little bit my report like this, so we can now see also what kind of groupings or what kind of information is in this bill of quantity present. Right. Seen from, okay, now I've closed DDS. 1 second. I accidentally closed the entire project. I saved the entire system. So once again, when we open up the complete building model for each stories, in this case, we can open up our rendering and we can investigate the building model. So we have started from an intelligent building model IFC file. We extended with the calculation for the airflow requirements from the building in relation to the spaces. Then we did some proper engineering on ventilation, ducting and system like that. And we can do an optimization on it. And of course we can add transitions. So we can go from duct, rectangular duct to round. We can add attenuators. We can insert dampers for doing fire damper. We can also insert heat exchangers in our duct system. And what I promise you about doing a clash detection, I will show you the clash detection on the ducts. So where we have the clash in the supply and exchange or supply and extract, we can now see that we have a duct clash here, and we can also here have a duct clash here. So we can zoom to the specific objects, and this clash can be seen not only visible but can also be checked, of course, automatically. So within DDS we are doing this internally, and what I now can do, I can split the duct like this, and I can delete this part of the system, and I can start redrawing again. So what I can do, I can say, okay, please detect the clash and please climb over it by using 45-degree angles. So in this case I don't have sufficient area, so I will start again and I will say please use a function, not 45 but use 90 degrees. And there is not enough room. Let me see, then I can do it over again with a distance of 0.5. There's not enough room. Okay, I will move this T a little bit. Climb under. There's not enough room of the bend. Okay, so I cannot insert the bend along this path. What I can do here, I can say I would like to have a split in here. I will delete this part and I will change this T. Then I will move the start point and I will move the T a little bit to here. And of course I can make the reconnection here. This is very simple. So we can make the connection here and then I can start. And now the system allows me to go up and over the other system. So now the connection is established once again. And we can say, okay, please make the connection from the endpoint here move the bend, start from the bend, where's my bend? Please move this one to here. Okay, sorry, I have to move the start point to here. So for doing this and changing this by avoiding the clash, we can now see that the pipe system is going underneath, and of course this can be optimized in many ways. So it is still about making the connections, about having the system in total. So this is the clash avoiding, and of course we can have a different height. So when I say I would like not to have this one 2.20 m, 2.40 m, then directly the 3D will be changed instantly. So this is the part on doing ventilation, and I would like to now switch to the next discipline, and the next discipline is electrical on the ground floor. So right, on ground floor we have the same information from the building model, and from the building model we can have we can see still the suspended ceiling. One of the main issues on electrical could be light calculations. So within DDS we have an internal light calculation function in which we can pick a specific room, and we can say, okay, this canteen would be recognized with a reflex factor and also a maintenance factor like a clean area. And based on the light fitting we are putting in, like a 2x36 tube light, DDS is proposing that we will have a orientation the other way around, or like this. Then we will have 2x5 light fittings for this specific room. Of course, when changing the room by doing not 500 lux but 300 lux, we can see that the information is reduced with one line in Y direction. So this is our very basic light calculation. We can see that also from 3D we can insert the information not only as an object, but also the object related to the room information. So we can see from rendering, I will prepare the rendering. Right, again I have to turn off my covering, and I will also turn off my suspended ceiling to look into the specific room. So these are my light fittings, and this is a very basic calculation on lighting. Of course we have much more powerful tools like Dialux or like Raylux, and these kind of tools will optimize the light calculations. So what we have inside DDS is a direct link in which we can export all of the rooms to Dialux, and we can open up the same project in Dialux instantly. So in the background Dialux is starting, and when I click here, Dialux is starting right now, and from the building information we saw in DDS we can focus on a specific room. For example, this room 006, the meeting room, and all of the information is now transported from DDS back into Dialux. And from Dialux, this is an extensive tool of doing planning on light calculation with a much more advanced possibility. So what I will do, I will insert specific light fixtures as a Lumia field, and within this field I can say I would like to use of different light fittings. So for example the Iguzzini MB45, that could be inserted as an arrangement for mounting plates 5 in a row, 7 in a row. So when I say I would like to have 4x6, I can insert the light fittings, and we can see them inserted in here. By doing the light calculation for this single room, the results will be shown in Dialux. And of course there are many tools, many CAD tools, which can have an export to a specific tool, and in this specific tool the endpoint of the results is the finish line. But within DDS we are going one step further. So this is the result we can see from doing an extensive light calculation. And in this tool we can also have, for example, we have our maintenance plan. But we can also influence the room surfaces. So in DDS we didn't pay attention to the damping on the materials used for doing light calculation or the light absorption. So in this case this tool can add the information like, okay, the walls are for bricks. So within bricks we have a different reflex factor, and this will also influence the calculation. And this is also a very powerful tool for doing these kind of light calculations. So now we can see the coloring in bricks, we can have a restart of the calculation, and it is all about making a decision based on something, and the something could be a result of a calculation or could be an assumption or an expertise level. So this is one room I've done, and of course we can add different rooms because all the rooms are available. So now I will save the information into Dialogs. Dialogs is saving the project right now. We have to wait for that a little while. Okay, the information is now saved, and what we can do directly inside DDS is within the dialog of the import to Dialogs, we can open up the file which we have saved as a result from Dialogs, and we can connect the light fittings to a DDS object. And that is necessary for us because we would like to connect this light fitting to a specific grouping. So we have the MB48 or the MB45, and these objects are created inside DDS. That means that from the extensive database from Dialogs, as we can see here from the Dialogs catalog, these lamp fittings are not all present inside DDS, and only the ones we need in the project can be created or can be imported. So once I've made the connection to my suspended ceiling in here, we can have the function of placing all of the lamps inside the room. We can now see in the background that the light fittings are imported inside DDS, and we can also import the ISO line for the result. So the result on this part is that we have 100 lux, 300 and 500 lux. And we can see now, maybe it's clear, maybe it's not clear, but this is the ISO line calculation from Dialogs inserted in DDS. So for us, it is important to have the information inside specific rooms. So this is the start point of adding information like switches. So in this case, we would like to have a double switch inside this room. And of course the information is in 3D available. So next to the door we have a snap point, and maybe we would also have next to the door, we would like to have a double socket, maybe horizontal or maybe vertical. When we put this in vertical, we don't have to take care on the height. We don't have to take care on which layer we are using to draw this object, because we are working object based, which means that an object can be searched and selected. So what I will do, I will say, okay, I would like to have some objects or like sockets here, and I would like to select the sockets in this particular room function, and I would like to use and change them from not only vertical, but I would like to change them to horizontal, only for these three. Right, I will put also a double socket horizontal in the kitchen, and the kitchen could have 2.10 meters height, and that's the room under my building. So these are two fittings on a specific light or a specific height, and I would like to make them to the wall like this, and I will change the height for this specific to 0.3. So this could be inside the cupboard of my board or my kitchen. Right, when I'm using a section, I would like to see in section view what I created with the light fitting, what I created with the sockets. So in this case, when looking to the section, we can see this switch, and we can see the sockets. And we can also see the light fittings. The switch is in the same position as my socket. So for doing 2D plans, we need to do something. And for this we can have a function called offset. We can put some as a little bit offset in our plan. And this is very difficult to understand, because when I would like to insert, for example, a data network, for example, a 2 times just network connection, it is a symbol, and I can set the symbol next to here. But when I do measurements, the width of the symbol is 20 centimeters. That means when I do measuring on a socket, the socket is 40 centimeters. And in real life or in 3D, I never see a socket of 40 centimeters. So we have to take care of what we are doing. So for this, when I put it in here and we look to the section again, we can also see here that we have the 3D symbol and also the socket for the IE LJ45. Right. Okay. One part for us is important for having the connections. So what we did on ventilation can also be done for doing the calculation on electrical. And for this, I would like to set up a distribution board. And from the distribution board, I would like to make connections. So this is my distribution board number 1. Distribution 1. I can place this symbol, and this is a symbol which can be used, for example, in the technical room in here. And we are defining from this distribution board, we are also defining our circuit list. And I will also make a new distribution board for the second level. So I will insert a new board. This is a subboard, SB1, subboard 1. And I don't place the symbol, but I will make a connection from the circuit in here. So first of all, on our distribution board, our main distribution board, we can say we would like to have a supply. And we would like to have a supply of 63 amp protective device with a B-type circuit breaker. We have to choose what kind of net we are using. And from the net, we can then say we would like to have an RCD protection. And we would like to have an RCD protection in 25. We can say we have 30 milliamps protection. This is RCD. And behind our RCD, we can insert grouping or one phase system for doing light for lighting connection. So this is lighting 1. We can once again add another lighting. This could be lighting 2. We can also insert sockets, and sockets could be inserted with not a B-type circuit breaker, but a C-type. When grouping is defined, we can also make a copy, of course, of this circuit. So when I say copy-paste in here, we have the new socket in here. So I can change the name to socket 1. When I press down, I can change the name to socket 2 very rapidly, of course. What is now happening is that our RCD is 25 amps. When I look to the single-phase circuit, this circuit is located on my phase 1. This means that the next circuit is located as a phase shifting on phase 2. But of course, phase number 3 could be used. What we can see here, 32 amps on phase number 1, because there are 2 groups selected to phase number 1. But I can also say, okay, I don't want to have a diversity factor of 1. I would like to have a diversity factor of 50. So 50 for both, and this will indicate that my nominal power of my RCD is still in range. So what I now did is for many reasons, is for multiple reasons. So what I would like to show you is the electrical schematic schematic of this distribution board. So the distribution board is defined not only for doing the connections to the sockets and to the light fittings, but it is also made for doing schematics. So when I insert a single line diagram or a multi-line diagram in combination with my switchboard list, I can define a schematic view of my circuit board. So my circuit board is defined like this. So we have the B-type circuit breaker 63, we have our RCD 25, and we have our B-type single core for the lighting 1, lighting 2, socket 1, socket 2. And you can also see that we have cables also attached. So this is our single line diagram, and we can also create automatically from our schematics our multi-line diagram. And of course this can be extended by objects. So when I would like to have a switch, a manual switch for some reason, I can say please put in a switch with one normal open, and I would like to have it drawn in this dialog. So I can draw the switch also by manual when applicable. Right. When we go to the next sheet, this is our switchboard list. Because nothing is connected, we can also see that we don't have any length. So the length of the cables we see here is not yet connected. So my distribution board is selected, and now I would like to have a logical view on which this could be going across my building. So first of all, I will draw a ladder, and I will draw a ladder from my circuit board somewhere to my building, also going through my corridor, and I will like to stop in here, and maybe I would like to have it reduced on this part, and I would like to have a reduction to a single tray, cable tray with a 200. Maybe the length could be 200 here. So you can see now that from this length of the reducer, after the reducer it is 200. We can see here also the cable height, 250. Once again, I can use a function by using a split. And when I make a split in here, I can delete this part, and I can say, okay, from here I would like to start at 2 meters 30. What I will do, I will make a connection from this part, and from this part we are starting, when I insert the part here, so start here. We are now at a height of 250, and when moving to the next ladder, it is indicating that we have an offset of 20 centimeters going down. And DDS is saying, okay, how would you like to have it changed? Please do it first horizontal, and then have it vertical like this. So then we have automatically also a small change in here as an offset, like this. Right. So this is 3D, which we can work, and we can also extend in here. We can extend towards the other side of this room. And we can go up here, a little step back. We can say, please make a connection to the next roof or to the next floor. Right. The cable tray is an indication for me to use trunking, and trunking is the logical path in which I would like to make a connection to my distribution board. So I will use the same function for going around my cable tray, like here. I will drop down to the specific height of 240 or 230 in this case, and from this trunking I will make the connections to my switchboard. So I'll make the trunk a little bit faster. Right. So I would like to use my distribution board 1, and from my distribution board 1, first I have to select it. I would like to make a connection on a socket. So what I will do, I will make a selection of a cable, and in this case I would like to have a single core cable in which I can search for H07 cable. This is my single core PVC, And I don't want to use 2.5, but I would like to use not 1.5, I would like to use 2.5. So now I'm going to make a connection from my trunking up to my socket. So you can see now that this socket is connected to the distribution board 1 on circuit number 5, cable number 5. And when I say, okay, this socket is selected, and I would like to change the marker for doing the grouping on the wattage, so this is 200 watt, we can continue from this cable. We can continue on the height. Let me see. Continue cable. Okay. From this height 0.3, we can connect to the other one. And now we get an indication that the length of the cable is not sufficient anymore. So instead of increasing the diameter of the cable, I will decrease the power of the cable. So maybe we only would like to have nearly 7 amps, or we would like to have 1.6 kilowatt, and then the cable is okay again. So we can make the connection, and this is the most detailed level DDS. So this is one socket connected. When I do the other grouping in here with the same cable name, we can say, please show me the used products. So this is my single core, and I can go from my trunk in here. I have to select the bigger size of cabling. Also the load could be lowered to 1 kilowatt. We can click inside here, and we can make the connection from here. And also from the cable length, this is very interesting to use, of course. So I will select another cable, and I can go from this socket. Sorry, I have to connect the cable. Continue cable, this cable. Right. I can go up on a specific height, 2.3. Then we can go across the wall or across the doors. And we're now looking in the section view. We can also see the cabling. So this is the most detailed level of cabling inside DDS. I would like to make the connection to the sockets and to the lighting. Once more, show me the cable, flat mode, what we are already using, 2.5. Click OK. And coming from the trunking in here, we can go directly to the switch. And when we go up to the switch at a height of 2.5, we can go to the sockets and now or to the lamp fittings, and now the lamp fittings will be connected. So this is something we have to do for making the connection, of course. So in this case also the length of the cable will be increased, or we can say this is just the 800 watt lamp type, so we can continue on a specific height. Right. So maybe on the other hand it will be connected on a different setting. So this could be the group indication on the switch. So the switch will be selected AB, and when we set only the A for which lamp will be switched, we can click on the lamp in here. And this can also be done in a multi-edit, of course. Right. To indicate what kind of cables are coming from the trunk, we have now 3 cables coming through the entire trunk, but maybe on this part in the trunk we only have 1 cable left. So the information is now added to the system. So here we have 1 cable. We can move it in here. Okay. And let's see. Okay, from here. So this is one part of the trunk which indicates 2 cables, and these cables can be also followed through the system. Right. This is a little part of electrical, and what I told you before is it also influences schematic. So when we now open up the sheet, we can see here that we have a total length of cable for 39.1 meters. And this is an end result for doing our bill of quantities, but it is also the length needed for doing calculations on voltage drop. So when I double click on a specific cable in here, we can have a load data, and we can use a function of calculating this cable. So from the maximum 3% of voltage drop, we can see that this cable length could be in the region of 69.4 meters. And we can now have a calculation and calculate the actual dimensioning by the use of an IEC 6364 based calculation. So from the results we do the calculation not only on voltage drop, but also on short circuit protection and also on overload protection. And of course, when changing one of the informations, like the diameter of the cable, so when I change it to 1.5, it will directly influence the maximum length of the cable. So in this case, we can have a 1.5, could be available, but maybe by local regulations we need to have a minimum of 2.5. Together with the cable installation method, we can predict, or we can not predict, we can calculate how this cable will react in an overload situation. So this is a situation connected to a wall. So these kinds of information are directly coming from DDS itself. Right. Of course, by doing a print, the information can be printed to a specific report. We can also have the cabling dimensioning as a list. This is the same list function will be reported. So now we have only one cable calculated, and we can see the length, we can see the type, and we can see also the grouping and also the device. The device is set on number 5. When I go to my sheet and I go to my circuit and I don't want to have number 5, but I would like to have it numbered number 50, of course everything can be changed from one source. So from building services perspective, the source is DDS. So when I now select my circuit and I change the circuit name from 5 to 50, and maybe group number 6 will be 51, this will be directly changed in my schematic. So we can see 50, 51. And this is also on the 2D. So when we look to my drawing in here, we can see now the group number for this specific socket is distribution board 1, group 51, cable number 6. When we would like to change the cable number from 6, we can change the cable number from 5 to 50 or to 150. We can change anything anywhere, and it is still selected as a system. So what we do in 3D on rendering, and one of the new features we have in the upcoming version is that we can also visualize the calculated cable lengths also in the 3D view. We can see our cable ladder coming out. So this is the cable ladder coming out, and when we look to the other side of the building, we can see our light fittings coming here. By moving through the building with a walk function, we can directly walk inside a specific room and we can look around. So when I move down to my ground floor, I can use and see what will happen inside my my space in this case. So this is my overview. And of course, from the 2D file, like a bill of quantity, we can have a report from the bill of quantity also located to the specific rooms. So the bill of quantity was quickly inside, and we can say, I would like to have a bill of quantity per room. So another report is generated with Crystal Reports, and these are my length. So we're doing this to the centimeter, and of course the amount of detail can be changed during the designing process, and it is all about information exchange, even without or even within DDS itself. So this will finalize the second discipline, electrical, and there's one discipline left. It's called plumbing, and within plumbing I can show you how we can do the same thing on ground floor, and there are some specific features I would like to show you. One of them is doing the connections on sewer system and sewer system with sloping. So what I prepared is a connection in my foundation. So from the foundation I will have a sewer coming in my building like this, and the sewer system is coming into the floor and will be connected to the next floor. So here we have a connection point. What I will do, I will delete this part of my subcircuit, and I will draw this one manual. So when looking in side view, we can see that there is a standpipe coming out. So I will put in a standpipe from starting from the previous floor going to the next floor. So this is my standpipe, and I can tell DDS connection automatically to the standpipe by using 45-degree angle. So this connection is created automatically in relations to the slope, as you can see. So maybe this is a connection available on a 45-degree bend. In the Netherlands, this is allowed. But of course, it can be changed by a 45-degree bend. I can do the same thing for multiple toilets in this case. So I select 2 toilets, and I can say, please connect them into the pipe into the ground. So the automatic connection from the sewer system is now created from the endpoint of the cold water system, or sorry, the sewer system. And when we look in 3D in render mode, I will render, and I will turn off everything except for my rendered inverse. Then we have the rendered sewer system, and because the sewer system is connected, we can also go to the 2D file and say, I would like to have a connection. But first I would like to connect also on this part. I would like to make a connection from the standpipe again in here, and this one could also be connected towards the pipe inside the floor. And this is done very quickly, but of course the engineer is always in control. So when something is not correct, of course the engineer should be able to change. That's one of the golden rules. It is never the software who's making the decision. It's the engineer who's making the decision. And of course, what we see in DDS, maybe this is the optimized system, or maybe we would like to have it dropped more to the bottom. Right. You can imagine when we go to this part, we have to the use of slope, that when we draw this part of the system, we don't know yet what the height will be for making the connection to the next floor. So what I can do, I can start or move the start point, and I can connect the start point to a pipe end. And now you can see in here, from the rendering, 1 second, I will, yes, this one was not saved. 1 second, inverse, inverse all, okay, rendering. So now I made a connection to this 50 millimeter sewer system in the background. Right, important for me for building services is to have a calculation point. So what I can do, I can set a calculation point, and because the systems of the toilets and the system of the male toilets are recognized. So for the calculation, I have a pipe which is ended to a slab above but is not connected. And now I can see that I have a toilet in here. I have 3 toilets and I have 2 urinals with the corresponding sizing. So by pressing calculate, we can see that DDS is calculating also what kind of bend, but also the liters per second for the system. So the slope is calculated, the liters per second is calculated, but also, for example, 6 liters is needed for the cistern of the toilet itself. And these informations are listed inside the system itself. So they are inside the toilet or inside a cistern. So once again, I can put text to this pipe segment. And from this pipe segment, we can say we would like to have a length system, we would like to have the flow, or we would like to have the slope also visible. So for the slope here. So this kind of information is directly inserted from DDS. So we can see the slope 1 to 100. We can see 1.8 liters per second. We can see 7 liters is needed for the entire system. So maybe we don't need this one, peak flow and flow for this. And you can see that from the drain slope, we have a header. But we can also change the header, of course. We can say, okay, the slope does not have a post text as liter per second. Or when we would like to change the settings on the sizing, we can use something like this, and we can change, of course, colorings. This is like a normal CAD tool. But the information coming from the liter per second in here, which is calculated, is directly from the cisterns we use in here. So we have from the direction of the database, we have an intake on 0.3 liters per second for a cold water connection, also for the flow pressure 500 millibar, and we need at least 0.8 liter per second for flushing. So this information is directly from the database and can be added and changed, of course, also by the user when he is using different systems to optimize. So in this case, we are using generic DDS components, but of course we can use for many manufacturers also corresponding databases. So one of the databases I will show you for doing the heating calculation. So I will switch back and turn on the complete renders or the complete layers. Let me switch back to 2D. From the 2D we have the building model, and from the building model we saw before that we had the information for the airflow requirements, and for the sanitary components we have the heat load. We have the heating facilities, we have the radiators, we have underfloor heating and the heating system, drinking water and drainage. Well, drinking or potable water is similar to the drinking water, and for potable water we are also doing calculations on the temperature of the return on the circulation pipe. So we have hot water to a sink, we have cold water to sink, and we have a circulation pipe system, and we can also do for potable water that kind of calculation on the temperature. Right. For the heat load, of course the heat load is very depending on the U values of the components. So for example, I have an interior wall with a very bad U value. On the other hand, I have 0.6 for the U value of an external wall. And this can be added from material layers, or this can be also added manual. The settings of the U value will directly influence the heat load. So first of all, when we look to the location, we can see that we are using Vilnius with the longitude and latitude. So this could be the street Opmergus 224, 223 in Vilnius. And this is the temperature set we will use for doing the heat load calculation. And one other thing for doing this is the direction, or is the orientation of our building model. So when we have 1.23 degrees for our north arrow, we will have the information directly from the heat load. So from the heat load, when the U values are correct, we can say I would like to have the one calculated minus 16.7, and we have to influence, is this a good surroundings of this building? Do we have protection? For example, nearby multiple offices, or do we in free land? What kind of system are we using for our materials? Is it very light built, or is it medium built with durable material? From the options, we can use the EN12831 for doing the heat loss calculation. This is an international norm, and by pressing calculate we can see directly the influence. And what is also influenced in this case is the system we use for the supply and extract air. Because we extract warm air, there will be put in cold air. So the system of supply air will directly influence the need for doing the heat load calculation. Right. The heat load calculation can be printed to a report which will indicate what we have. So when we extend the report function, the information will be fetched and will be put into a crystal report again, and this information is on every space, so it will be collected and will be centralized. Of course, during the designing process we can see also these information, for example, in our room list completely here. So we can see which rooms is heated. We can see also the heat load, and we can also see that this room will have some additional heat available. Right, this is the report on the heat load. In total 37 pages, because every space is indicated separately. So we have a summarize, and this is information, as we can see, also the air tightness and also the ventilation which is used inside the specific room. So for example, here we have supply air in this room, and this will influence also the temperature set for doing the heat load in this particular room. So this is a very extensive report in which we can once again make our decision, and the decision can only be made on information. And when the information is coming from experience, that's the best part, of course, because I need to make sure that the 30 kilowatt or 33 kilowatt as assumption for the heat load is somewhere in the exact range. So for example, when I design a car and I got a weight of 5 million kilos, then I know for sure that something is wrong with my design of a car. So you need to know the experience of figures. So the result of DDS is just the result, and the engineer needs to do his perform whether the result is appropriate or not appropriate. Right. So what I will do, by showing the information for this room, we can also see from heat load where is our most losses will go. Right. For the building model, we can say from heating we will have radiators on this particular story, and I will later on put in underfloor heating for the next story. So now this radiator set for this entire building, and now I can say for the entire story I would like to insert specific heaters, and I can open up particular databases. So in this case I'm using a German database of Brüche. Brüche is a manufacturer database of heaters. So when we have the Europlan Compact series, I will have an output on priorities that, first of all, the output of the heater should be reached, and later on secondly the height and the length of the radiators could be influenced. So I got a notification that there's something wrong with the sound. So I'm asking Mark whether he can still hear me.
Yes, you're perfectly fine. Please go ahead.
Okay, I will continue. Right. So from the priority of making the calculations on the radiators, when I zoom out a little bit in here and I press calculate, by pressing apply, we can see that from the database in here, inside the specific room, radiators are set. So the radiators are set in here, and as we can see, this room is only limited with one window. That means that from this window, to have the complete heat load reached by the radiator, we have to insert a bigger radiator. So this is done automatically coming from the database. So I will put in here the heat load. So in this case we have 1.6 kilowatt, and when we influence the radiator here, we can see that we have a maximum of 1.943. Right. And of course it is time for making the connections to a specific region. So what I will do, I will put in from the boiler type, which is also coming from our database, I'm making a connection to a system with a heat flow and a heat return. And you can see that the object itself is also intelligent with heat flow and heat return. So I can drop down into my floor, and I can go underneath the floor. I can go in here, and I will make a circle, or I will make a path along the system, like here. Going back to the radiators, or to the heating component, this is my heat flow. I also have to need to make the connections to the heat return. And when hovering above, I can see that I have two heat flow connections and also two heat returns. So I'll drop down once again into the floor, and I will go a little bit to the back, and I will follow the same path for my radiators in here. So I can use functions like zoom by clicking. And this is my final part. When I select the radiator, I can use the same function we use also for the sewer system. And I would like to, I have to check something. 1 second. Checking in 3D. Repaint. Let's see. Okay. So this is my heater, and yeah, I'm coming into the floor for my my heating component, my heat flow and heat return. That means that I should be able to connect this radiator directly to the floor, like this. Direct. Okay. This radiator of Brugge has multiple connection points to one side, so I have to indicate which side I would like to make the connection. So for example, the heat flow and heat return is connected to both sides of the panels, so then it will be automatically recognized by DDS on this way. And once again, when we have done this for one panel, we can do this for multiple panels by selecting all of the heaters. By pressing close, we can use function. We'll do it like this, selecting heater of the same type, and I'll only select the heaters in this region, otherwise I will get error messages that the rest of the heaters cannot be connected. So this is done directly. I have to indicate the point of making the connection. So first of all, I will have to indicate the flow, then I have to indicate the return. And there was a message, there was a very short message about clashing, and clashing can be done also later on. Right, when we now look to the system and we zoom to this particular radiator, we can now see that we have a system on heat flow and heat return. And once the system is connected, we are entitled, or we are able to do the calculation again. And from the calculation we can we can choose the start point. I will select this one and choose the starting points. This is my starting point. This is the calculation of the heating. But because it is a system with a flow and a return, I also have to introduce to my start point of the heat flow that this one is connected to the same system heating. So when I now press calculate, DDS is calculating from the pressure drop into the system, and we can say we would like to have a maximum water velocity or we would like to have a maximum pressure. So we can either choose from one of the two settings. By pressing calculate, DDS is also optimizing the system. So we can see, for example, a pipe sizing of 100. By pressing calculate, it should be reduced to 20, 15 and 12. So DDS is automatically inserting reductions. By pressing OK, we can transport the information back to the system again. So now we have the calculation points, and we can say from this part I would like to have the pipe segment, and I would like to have the flow and the return also here. So we would like dimensioning flow, we would like to have velocity and absolute pressure. So this can be turned on and off very rapidly to indicate what kind of system do we have. When we are on the radiator itself, we also have valves included. The valves are not shown in the 3D, but they are also in the calculation results. So we can see the kV value on 4.4 Pascal, and we can see 1.5 cubic meters per hour. When we have adjustable valves, we can also go to the building information for our heating system, and there we can see from the tab of our calculation that we can also have adjustable valves in which we would like to have the worst part included, and we can have the kV values on every single radiator, and this can be used for doing the ordering form already. So, right, so this is something on heating with traditional. We can also have function for the building in which we can see that we would like to have for the story, we would like to have underfloor heating. So this is done very quickly for the entire story. And with underfloor heating, I can have the use of a Tecker system, for example, Uponor. So we can have Uponor for underfloor heating. And from Uponor, I can also have a Provario system. Let me see what we have here. Yep, we can have 7 string manifold. And the manifold is located in here, for example, and we can draw from the specific room, for example this room, this should be with underfloor heating together with this room. And from the room part properties we can see, I have to change this one, from the room part properties we can influence for the underfloor heating. We would like to have a pipe distance 250, or we would like to have a pipe distance 150, or we would like to have different regions. So for example, when we have an extra heated region, we can draw this a little bit back. 1 second. We can have this one parallel like this, and also with this one parallel with this, parallel. Move parallel lines like this, like this. It is still a polyline, and what I can do, I can say I would like to draw in the rest of the region. It could be merged, or we can have a automatically draw like this. 1 second. I have to turn off merge. Parallel. Alright, yeah, I know what's happening in here. Yep. Because there is a small angle around the corner, I was not able to have it differently. But Yeah, we can have also different settings. I will show you this in the calculation. Right. For the options on the calculation, we can start with the optimum of the temperature, like 45 of doing underfloor heating. When pressing calculate, for each room in which underfloor heating is detected, we get a notification that the outcome of the heat flow is not sufficient. So in the room we need 3 kilowatts, and only the underfloor heating is providing 2.2 kilowatts. So the underfloor heating is automatically divided for the systems. So we have 1, 2, 3 systems in here, and when we put in the part text and we say we would like to have information on the system here, we can see that we have 250 on difference in length, or that's the pipe distance, and the total length is 105 meters, and this is set as normal temperature. We have the same information in here, and when we look to the room information, we can see why we don't use the heating facilities. So 100% we need to have 3 kilowatt, and the underfloor heating is only providing 75. So what we can do, we can say we would like to increase or decrease the amount of pipe distance to 100. What I now will do is I will merge the rest of the system like this, and I will do a recalculation on this specific room. So calculate, and still I cannot reach the entire system for doing recalculation. For me that's another point of interest, because when changing the temperature like 50 and see what happens, I can have a recalculate very quickly. So with this recalculation on a higher temperature from the supply, I don't get any notifications. So it is in case when looking to the room information, underfloor heating, we can see that from the heating facilities we actually have 1.1% filled for this room. So what is necessary to know is that this segment has a pipe distance of 100 meter, has a pipe length of 103 meters 82, and also has a connection length to the distributor of 18.13 meters. And when we now go to a bill of quantity, or when we now export to a report for the underfloor heating, we can have a print. So the information is completely listed. So once again a report. Yes, I would like to show the information on the report. Now the information is fetched again. So this is in a very nutshell what we can have for doing the calculation on heating, underfloor heating. So we can see here that we have 2 rooms with underfloor heating. One of them is in 206%. That would indicate to me that the pipe distance used in this room to do an optimization and see what happens. So with a higher temperature, we have a different setting to have to set the target output. Right. Of course, what I showed was just a brief possibility of working with DDS CAD as a designing tool. It is all about information. We started with an intelligent building model, and from the intelligent building model we can have the information linked to each other. The information linked to each other is directly available in calculations tools, and of course it is not only one discipline, it is the entire building services as a total, and there are much more disciplines. So DDS is covering a lot of features like gas, sprinkler systems, cooling systems or cooling fans, radiators, hot and cold water, and the nicest part of them is when we open up different features. So when I say I would like to show not only the 2D representations but also the 3D thickness of the system, you can imagine when I put in this pipe segment I put in the insulation like 9 millimeters, that also the pipe itself will increase. So insulation for the heat flow and also for the return will say, okay, there will be a clash in this part. So what we can do, we can move this bend to avoid the clash. And this is doing optimization and in the different phases of the system, we can go and step into detailed level. Right. I would like to finish with a combination of the ground floor and the combination of the ductwork on the ground floor. And then I would like to show you what will happen when we watch in render what we have now designed. So this is a pipe net system in which there could be multiple clashes. And I don't know whether I have forced clash, yes or no. It seems to be very okay, but now I'm in pipe work, and when I say, for example, when we are going from our cold water connection or the heat return, I will have a T part. I will have a T part in here, and I will drop to the floor, or I will have a T part in here, and I will go to the next same floor in here. We're now looking to the 3D. This will be, of course, a clash. So now I've created a clash in here. And we can see from the clipping, we can see from here, we would like to investigate on this particular part, or maybe we would like to have from this part a little bit checking. So with this is information, and based on the information we can see in the screen, we can influence our decision once more. So when doing the clashing with pipe, duct and ladders, we would like to have, yeah, of course, here we have some clashes. We can zoom to the object. We can say in 3D, using of a BIM collaboration format, we say first issue, capture what we have. And at any time, I can go back to a specific point. So for example, when I'm here and I'm working tomorrow and I would like to focus on the specific point, I can double click in here and I have directly the same site as my BIM collaboration format. Of course, exporting to IFC is directly inside DDS available. And yeah, this will include my part of showing DDS as a designing tool, and a designing tool by optimizing the results, and the results is an extraction of the information we put into the model. And the more information we put in the model, the sooner or the more we can extract information from that model. So I would like to close my part of doing the MEP. At the latest part, last part, I included every system as a combination. So if any questions, feel free to ask, and I will now give the word back to Mark.
Thank you, Gertjan. Thank you for demonstrating. During the demonstration, we received quite a few questions from the attendees. Let me just briefly go through a few of those. Because we had a question regarding the recording of the webinar. That was one at the beginning almost. The webinar is fully recorded, and we will, shortly after this webinar, we will make it available for download. So you can always take a look at it again or send it forward it to your colleagues. Another question was regarding hardware requirements. The hardware requirements for DDS CAD is actually, it runs on standard office equipment. We have developed this software internally in-house since 1984. It has been always focused on speed, so that normal projects of a decent size and the complexity can still be planned on normal hardware equipment. On our website you will find hardware requirements for like the minimal one, standard hardware settings, but also for a high-end hardware configuration. So more detailed information can be found on our website. Another question was regarding the ventilation. When we drew the ventilation shafts through the walls, there are no holes in the walls. And that's true because we appoint our builder works inside the building discipline. And in the building discipline, we can appoint our builder works. Those are the holes inside the walls. And we can export, for example, those builder works again as a separate IFC file for the structural engineer in order for him to appoint it into his precast concrete elements or prefab elements. Another question was, we're working together with multiple people inside the same project with DDS CAD, and that's possible as well. As you could see with Getjan, when he was switching to different disciplines, it is possible within each discipline to work together with engineers on the same level inside the project. So if we took the ground floor, we can work simultaneously with an electrical engineer, with a plumbing engineer, and an HVAC engineer. So if you have a building of 100 stories high, theoretically you could work together with 300 people at the same time on one project. Furthermore, there were another question just coming in regarding the email address. The email address will be forwarded. We have our partner in Vilnius Intelligent BIM Solutions. They can be always contacted in case you prefer not to communicate in English. They will take all our questions and they will answer them to you, and else you can also always contact us directly via info@ddscad.com. To all attendees, we will forward our contact addresses so you are able to contact us after this webinar. Then there was another question regarding water supply, but it was not a really detailed question. So if you could elaborate a little bit more, perhaps after the webinar, we can definitely answer or go a little bit more into detail regarding your question for water supply, because DDS CAD has functions for potable water, for like drinking water, etc. So it's similar to heating networks. It's only a green pipe then. We can do similar calculations for potable water networks. So hereby I would like to conclude this webinar. We are a few minutes overdue, but that's okay. I guess it's less than 5 minutes. I would like to thank you all for attending this webinar. And if you would like to know more about the DDS CAD, feel free to contact our partner Intelligent BIM Solutions in Vilnius, and we will send you an email in which the webinar will be made available online as a download. Thank you very much and have a nice day. Cheers. Bye-bye.